Let me ask you a question. Can a machine actually learn on its own? I don't mean just following instructions, but truly learning from experience, the way we do. It's one of the biggest questions of our time. And honestly, the answer is changing absolutely everything.
And even begin to answer that, we've got to dive into the world of machine learning. So what do we even mean when we say a machine learns? At its core, it's about getting computers to do things without us having to write out a specific step-by-step instruction manual for every single task. Okay, so think about traditional programming, right? You tell the computer exactly what to do. If this happens, do that. It's all hard-coded rules. Well, machine learning completely flips that idea on its head. It's this whole field of AI where, instead of giving it rules, we give it a ton of data and just let it figure out the patterns in the rules for itself. And that's the key. It learns to do things without us micromanaging every little step.
There's this really great, kind of formal definition by a computer scientist named Tom M. Mitchell that just nails it. Let's break it down real quick. T is the task. Let's say figuring out which of your emails are spam. E is the experience. That's just showing the computer thousands and thousands of emails that we've already marked as spam or not spam. And P is performance. That's its report card. How good is it at spotting spam and new emails it's never seen before? So it learns if it gets better at the task as it gets more experience. Simple as that.
And, this idea isn't brand new. The term itself was coined way back in 1959 by Arthur Samuel at IBM. He made a checkers program that eventually learned how to beat him. Now, the field had its ups and downs, but then in the 80s, a huge breakthrough called backpropagation just supercharged everything. Fast forward to 2016. Google's AlphaGo does something incredible. It beats one of the best Go players in the world. I mean, people thought that was decades away. It was a huge moment.
So how does this learning actually work under the hood? Well, it really just boils down to three main ways, three different styles of learning.
All right, first up, you've got supervised learning. The best way to think about this is like a student with a teacher. You show the machine tons of labeled examples. This is a picture of a cat, this is a picture of a dog. Eventually, it learns to tell the difference. This is exactly how your spam filter works. Then you have unsupervised learning. Here, there's no teacher, no labels. It's more like a detective sifting through a giant box of evidence, just looking for hidden clues and patterns. This is how a company might discover different types of customers they never knew they had. And finally, there's reinforcement learning. This one's kind of like training a pet. The machine tries something, and if it's a good move, it gets a reward. If it's a bad move, no reward. Through pure trial and error, it learns to master things, like a video game.
And I have to stress, this isn't some abstract, futuristic idea. You are interacting with these systems every single day, probably without even realizing it.
Just think about it for a second. How does Netflix seem to just know what show you'll want to binge next? That's a recommendation engine powered by machine learning. Or how about when you start typing in Google and it finishes your sentence? A little creepy, but yep, also machine learning. It's the engine behind your smart speakers, those real-time translation apps, and yeah, even the ads that seem to follow you around the internet.
But it goes so much deeper than that. We're talking about serious, high-stakes applications. It's on the front lines, detecting credit card fraud in real time. It's analyzing financial markets and helping robots learn to walk. And in medicine, it's being used to analyze medical scans to find signs of disease far earlier than the human eye might catch. And it's helping scientists classify DNA sequences. It's truly pushing the boundaries of what's possible.
Okay, so this technology is incredibly powerful. But, and this is a really big but, it's not without its dangers. Since a machine can only learn from the data we give it, we have to ask a critical question. What happens when that data is flawed?
The first major problem is something called overfitting. Imagine you're studying for a test, but instead of actually learning the subject, you just memorize the practice test, every single question and answer. Well, you'd ace that practice test, right? But the second the real test asks a slightly different question, you're toast. That's overfitting. The AI memorizes the data instead of learning the general rules, so it fails when it sees something new.
When you've got the black box problem, this one's a little spooky. Some of the most powerful AI models are so insanely complex that even the people who designed them can't fully explain why they make a specific decision. It spits out an answer, but you can't ask it to show its work. And that's a huge problem when you're talking about a medical diagnosis or a legal decision, because the computer said so just isn't a good enough answer.
And that brings us to what might be the most critical challenge of all, algorithmic bias.
A machine learns from the data we give it, right? So if that data is filled with all of our historical, societal, and even our unconscious biases, well, the machine learns those biases too. It doesn't just mirror our prejudices, it can actually amplify them, turning them into code.
And listen, this isn't just the theory. This stuff has real damaging consequences. Back in the 80s, a medical school in the UK used a program to help screen applicants, but it was trained on old admissions data that reflected the biases of that time. The result? It started discriminating against women and people with non-European-sounding names. Or, much more recently, an algorithm used in the US justice system was shown to falsely flag black defendants as future risks at nearly twice the rate of white defendants. The AI wasn't racist. The data it learned from was a reflection of a biased system.
So as this technology gets woven deeper and deeper into the fabric of our lives, where does that leave us? What is our responsibility in all of this?
The brilliant AI pioneer Fei-Fei Li really said it best. She said, "There's nothing artificial about AI. It's inspired by people, it's built by people, and most importantly, it impacts people. It's this incredibly powerful tool that we're only just beginning to get our heads around, and that, she says, is a profound responsibility."
So, at the end of the day, it all comes down to this. We're teaching these machines to learn from our world, from our data, from our history. But in doing that, they're basically holding up a giant mirror to our society. So the real question isn't just about the technology, it's about us. We're teaching machines to learn, but what are we teaching them about who we are?